Hey guys, so today we are going to learn about an interesting data structure called linked list. We're going to understand what linked list is in a very simple language, and then we're going to compare it with arrays and how it differs. And we're going to have a coding exercise where we build a class, a linked list class with some methods like insert and remove and find. By the way, I have an announcement to make. And that is because these days, if you go for an interview, it doesn't matter if it's a front-end interview, back-end interview, or QA, you are probably going to be asked questions on algorithm and data structures. And so me and a couple of my friends, we are putting together sort of like an online training where we teach you front-end, back-end, and prepare you basically, should I say, for front-end, back-end, and algorithm and data structure, and even some how to psychologically dealing with the interview, and we'll have some mock interview in the end. So if you're interested, contact me. I'll provide an email address in the description and at the end of the video. And welcome to Texas Tutorials. All right, so let's try to understand what is a linked list first. And for that, I'm going to give you an interesting example. So I play this video game called Uncharted, and the way it works is, in the beginning you get some map, and it's a treasure map, and it has some clues. So based on the clue, you go to that location, all right? And then when you get there, you don't really get any treasure. You might get some small things, but then you get another map, which will basically say, oh, there's some treasure on this side here. So then you go there, and the same thing, you'll get some small things, nothing big, but then you get another map, and you keep doing it until the end of the game where you hit the mother lode of the lots of gold or something. I haven't reached there, but that's the objective. So the thing is, you cannot really cross the whole thing. You have to go from one treasure map to another. You cannot simply go to the last level. So linked list is something like that. So let's say instead of treasure, we're gonna have some values, right? So let's start our linked list. So what we're gonna have is some head. So this is our beginning of the linked list. And each node here will have some value. So let's say it's going to have value 1. And it's going to have some address. Basically a map to the second node, like a second level treasure, right? So I'm just going to draw it like this. It's almost like a pointer. And let's say this is the second level, and here I'm going to have some value also. Let's say I have 5 here. It will have an address to the next level. Okay, and here I hit my mother lode. I'm going to have, let's say, 100 to represent the final treasure. From that point, I won't have any more maps, so I can call null because it doesn't point anywhere else. So I have come to the end of the game. So this is my typical linked list where I have each node would have a value and address to the next node, value and address to the next node until you reach the end of the list. Now the funny thing about this linked list is that each node is stored somewhere else. They're not consecutive memory, unlike arrays, where they're stored in a continuous memory. If I want to build a linked list, I don't really need to reserve continuous space. So that's a huge advantage for linked list. Now let's build a similar array, right? So because it's an array, I'm going to have sort of like a, let's call sort of like a rooms. Okay, so if I want to have a treasure map, they're in a consecutive rooms. So here's the array A, for example. I call it array A. and it has the same values, 1, 5, and 100. So now if I want to go here, I don't really have to visit A and 5, 1 and 5. I can simply do this 2, because this would be A0, this would be A1, and this would be A2. Because they are continuous memory, you can easily find A2 without visiting this 2. It makes a difference if you have a much larger array. Compared to here, I have to go to 1, then go to 5, and finally I can be at 100. But the problem with this kind of data structure is like array. Let's say if I want to insert 3 between 1 and 5. I want to do that. What I have to do is, if I want to insert 3 here, because it's continuous, I have to move this one place, and then I have to move 5 where the 100 was, and then 3 would move in where 5 was. That's not very efficient, because from where I'm inserting, everything would move one place. Same thing with the deleting. If I want to delete, let's say 5, when I delete 5, 100 has to move here. And this is a small array, so it doesn't look like much. But if I have 1,000 elements, and if I am changing the front, I have to move the rest of the 999 elements forward. Compared to here, if I want to add, let's say, 3 here, so I'm going to create another node here, 3. Now, I want to insert between 1 and 5. So what I will do is take this and point this to here, and then I can point this guy to nav 5. Simple. It doesn't matter how long my linked list is. This becomes very simple. Nothing changes from here. So if I'm storing different values, inserting is very cheap. Here, inserting and deleting is very expensive. However, here, finding things very easy compared to here. So that's a thing to remember. All right, so let's start coding. I'm going to use JavaScript since I'm most comfortable with JavaScript, and I'm going to use classes. So for those people who know Java can feel familiar. Yes, JavaScript has classes. If you don't know how it works, I have a tutorial on it. I'll provide a link here. So let's start with creating our node class. The syntax would be class node, and I'm going to have only constructor on it. And this constructor take 2 values. As we looked at, it will have value and it would have next. And I can set a default value to null, just in case if you don't provide it, it would be null. I can say this dot value equal to value, and this dot next equal to next. All right, so I can actually create a new node. Let new node equal to new node, and I can provide a value, x, y, z. That with the text, the value, and I don't really need to provide next. It will be null. Or I can provide, if I have another node, I can provide a reference to its next value. Okay, so this is how it's going to work. Okay, so now let's create our linked list. So that will be also a class. I'm going to call it list. All right, so we're also going to have a constructor. As we know, all we need is head. So this would be this dot head equal to new node, and we are going to call it head. All right, so this would have null as the next. All right, so the first thing we need is a find method, because if I provide a particular value, I need to be able to find that node. So I can say find, and the find method takes a value. So we are finding by value. So let's create a temp node first. So I'm just going to say temp node, and that will be equal to this dot head. And then what I'm going to do is I'm going to have a while loop, and what it's going to check is if the temp node dot value, if it's not equal to the value that I am passing, which means it cannot find the value, then it has to go to the next node in the list, right? So then it has to go to the next node. So it would say temp node dot next, and then it would do it again until it finds a value. And once it finds it, then it should simply return it. So it would say return temp node. Okay, so that's our find. Now let me just tidy up. All right, so what else do we need? We would need to insert a new node. So we can have an insert method. So in insert methods takes two arguments. First argument should be where are we inserting this node, and what would be the value of that node. And the where should be also a value. The first thing we need to do is we have the where, which is the value, right? So we need to find this node in the list. So I can say node where to insert equal to this dot find. So if you want to access this method, I have to say this dot find, and what we're trying to find is a where. Okay, so once we find that node, which is where, now we need to do two things. Once we find a node where we need to insert, right now that node has a pointer to its next would be the next node. So we need to change that to this new node that we're gonna create. So what we're gonna do is we can say let new node equal to new node, and the new node's value, it's going to be nothing but this value, the one we're creating, right? And its next is going to be where to insert node. Remember, we are breaking that link, so where to insert is the node where we are inserting, right? So we're gonna take its next and point it there, and then what we're gonna do is we now need to change this equal to new node. So we are kind of inserting in between the where to insert node and its next node. Okay, now let's have a print method. So what the print method would do is it would print all the node in the list. So that would be simple. So it would say first always temp node equal to this dot head, and we can have a while loop which will basically say if temp node is not equal to null, which means until we go to the last node, we just need to print the value of the node. So here what we want to do is we just want to console log out the temp node's value, and once we print the value, then obviously we also want to go to the next node. So we can say temp node equal to temp node dot next. All right, that should be enough for now. We can add some more methods, but let's now use this to create our list. So I can say let new list equal to new list, and I can say new list dot insert. Now the first node we need to insert obviously at the head, because that's all we have, 1. Okay, so that's the value, and then I can do the same thing. I can say insert. Now the second value I want to insert at 1, and that will be 2, and the third value again I want to insert is at 2, and that will be 3. Okay, and if I just print it, so I can say new list dot print, that should print head 1, 2, and 3, right? So let's run this. Okay, there's an error because I said temp node. I always make that mistake. Do I have anywhere else? All right, hopefully that should few more places. Okay, so now if I run this, I would get head 1, 2, and 3. Now let's insert 4 between 1 and 2. So the way to do it is, again, a new list dot insert, and I'm inserting 4 at 1, right? So that should make it 1, 4, 2, 3, right? So if I run this, I would get 1, 4, 2, 3. So it does work. All right, now let's add some more things. By the way, I'll provide a link in the beginning, in the description, so you can have access to this code, and I'll put it on the GitHub. So, all right, so let's, next method should be remove. So we should be able, since we can insert it, we should be able to remove it. But for removing it, we need to find a previous node. So I'm gonna have a method called find previous. All right, and just like for the previous node, we are looking for a value. So if I enter, for example, if I enter 4 here, right now I have 1, 4, 2, 3. So if I put 4, it should give me 1. Okay, and the reason to find previous, so when I'm removing, I need to find a previous, so I can remove the link from the previous for the next one. So as usual, we need to first do this. So the temp node equal to head. So we always start from the temp node. Then we can have a while loop. And so what we're gonna do is we can say if temp node dot next dot value is not equal to the value. So what we're trying to do is, let's say if I'm looking for the previous node, then I should find the value in the next node. So that would be my previous, right? So that's what I'm trying to do here. Also, I need to, if it reaches the end, so I can say temp node dot next dot value is not equal to null, which means it's not at the end. Then what I need to do, simple, temp node equal to temp node dot next. All right, once I find it, I can just simply return the temp node. So whichever value I provide, it would find me the previous node. And the last thing I want to do is remove method. So what am I removing? I'm removing a value. So let's say if I want to remove a 4 from here, so I would provide remove 4. And here the first thing I'm going to do is let temp node equal to, let's find the previous. So I can say this method and value. So now I have the previous node to where the value is located. If temp node dot next is not equal to null, basically if I'm not the second last node, then temp node dot next equal to temp node dot next, because I need to remove the link. So from the current node that I'm removing, I need to remove its link to the next node, so that my previous node would have the link to my next node, right? So that's what I'm trying to do here. All right, so here in this example, I have inserted 1 at the head, 2 and 3, and then I inserted 4 between 1 and 2. So now let's remove the mismatch 4. So I can say remove 4. All right, so that should straighten out our head 1, 2, and 3. So if I run this, I would get head 1, 2, and 3. So this is how it works. So it's pretty simple. Let's say if somebody asks you a particular algorithm regarding linked list, you would need to have add method, you would need to have find method, insert method, and hopefully remove method. And obviously you would need print method. So this would give you the structure that you need to write that code.